Here we're going to look at a formula for theoretical probability. A theoretical probability for an event E will be given by finding the number of ways that an experiment can happen, and then seeing which of those ways are favorable to event E. To demonstrate it, I'm going to go down here to number 3. Let's say that we want to find the theoretical probability for a fair coin landing on heads. First, we may want to examine the tree involved in flipping a coin. So we all know there's two possibilities for the tossing of a coin, heads and tails. So we want to write that down, that there are two ways the experiment can happen. Okay. And then we also want to know, of those two ways, how many of the outcomes are actually favorable to our event. So our event is landed on heads. So the number of outcomes that are favorable is 1. And all we want to do now is just divide to find the theoretical probability. So the probability of event A here will be the number of outcomes that are favorable divided by the total number of outcomes. Here it's going to be 1/2, 1 over 2. And if we turn that into a decimal, we'll see that it's 0.5. And if we turn it into a percent, that's 50%. All three of those are correct answers. So we know that half of the time our coin is going to land on heads and half the time it's going to land on tails. But that's only if the experiment were repeated an infinite number of times. And that's something that I'm going to look at in my next video. So what would it mean if a theoretical probability of an event were to be equal to 1? So since it's theoretical, that would mean that every way that the experiment can happen is favorable to the event A. And so in words, I would say this. Event A is certain to occur. Keep in mind this is theoretical now. It's not necessarily real. But we can give an example of this. You might also say event A will happen. Give an example of that shortly. And then what does it mean for a theoretical probability of an event to be equal to 0? Let's say the probability of event B were 0. Well, then event B will not happen or will not occur. Let's see if that happens in some of these down below. So number 4 is event B is rolling a 3 with a 6-sided die. Can we find the theoretical probability of that? I'm going to draw a tree for the experiment. Rolling a die has 6 outcomes. So we're going to want our lower denominator here to be 6, but we need to know how many of those 6 outcomes in the sample space are 3's. And so if we check out our tree, we see that there is one outcome in the sample space, which is in agreement with the event B. So you don't want to put a 3 on top, because that's just the name of the outcome here. We have to say how many times it occurred in the sample space, which is actually just 1. As a decimal, it's 0.167 approximately. Now, what about the probability of rolling the number 7 with a 6-sided die? So, since the rules of a die are that there's 6 sides, and the numbers 1 through 6 are on the sides, then when you look at the tree for the die, it's like, do we see a 7 in there? And the answer, of course, is no. So in that case, we would have 0 outcomes which are favorable out of 6. And if we just simplify that, we'll see that the probability of rolling a 7 is actually 0. That's an example of where an event will not occur. But if we look at event D is having the result be a number less than 7. Well, when you go to the tree for that, 1, 2, 3, 4, 5, 6. It's like, is 1 less than 7? Yes, so it meets the criteria. Is 2 less than 7? Yes. Is 3 less than 7? Yes, and so on. They're all less than 7. So this is an example where every outcome is a success. So we would put 6 out of 6, which simplifies to 1. So it's certain when you roll a 6-sided die, you will get a number less than 7.